A. Color and magnetic properties of d block elements. First of all, color compounds. Transition elements usually form colored compounds. The splitting of d orbitals of metal ion takes place under the influence of the surrounding ligands. The d orbitals are split by the surrounding ligands into two sets of orbitals of low and high energy. The energy gap between these two levels is comparatively small. Consequently, the excitation of an electron from lower to higher D level can be achieved by absorption of visible light, which cause the transition metal compounds to appear color. Transition elements usually form color compounds due to incomplete filling of the orbitals, where absorption of light could lead to DD electronic transition. For example, zinc, copper, does not usually show colored compounds. Zinc plus 2 D10 and copper plus 1 also D10. Does not usually show colored compounds due to complete filling of d orbitals, and hence the transition is not feasible. Similarly, titanium oxide is white because titanium plus 4s2, 3d2, only 4 electrons, so d0 configuration and d levels is empty. In the series of scandium, vanadium, manganese, 7, vanadium plus 4, scandium plus 3. These ions have empty d cell and hence dt transition are impossible. That's why they are colorless. Those transition metal compounds having central metal ion with empty d orbitals d0 or completely filled d orbitals d10 are colorless. There is no possibility of DD electronic transition, and no light of any color or wavelength is observed by such compounds in visible region. The colors of observed light and transmitted lights are different from each other. The color of transmitted light is called complementary color of that observed light, and the color of the transmitted light is color of the compounds to our eyes. For example, copper 2 plus salt absorbs yellow radiation. It transmits blue radiation, which is complementary color of yellow light, and hence the salt look blue to our eyes. And magnetic properties. When substance is placed in the magnetic field of the strand of strand hydrogen, the intensity of the magnetic field induced by the substance S naught may be greater than or less than S. If the total magnetic field induction B inside the substance is greater than the applied magnetic field S, magnetic field intensity S, the substance is paramagnetic. If the total magnetic field induction B inside the substance is greater than the applied magnetic field, the substance is paramagnetic. that is weakly attracted to magnetic field. If the field inside the substance is less than applied magnetic field as the substance is diamagnetic, that is weakly repelled by the magnetic field. For paramagnetic materials, relative permeability mu are greater than 1, that is B is greater than S. That is the induction magnetic field is greater than applied magnetic field. And in case of diamagnetic materials, relative permeability mu r is the less than 1. That is the induced magnetic field is less than applied magnetic field. Yes.